Alright, so today I want to talk about energy in the oscillation. So we've looked at the graphs and the acceleration and all this, but where's the energy going? And I turned it on its side here a little bit, this piece, so I can take a look at I want to look at kinetic energy and I want to look at spring energy. So first I want to look at how are these calculated. So kinetic energy, remember, is 1/2 mv squared, and the spring energy, the potential spring energy, is equal to 1/2 kx squared. So how much does it stretch? The spring constant, and then 1/2 of that. So the total energy of the system, the reason it's on its side is so that way we don't have to deal with any UG, or gravitational potential energy. And so my total amount of energy, put E for that, is going to equal my kinetic energy plus my spring energy. So if I put the real numbers in, then 1/2 mv squared plus 1/2 kx squared. So here's some ideas I want to look at when we're talking about this. And that is going to be, at what point is kinetic energy the highest, and at what points are spring potential energy the highest? And this question is really simple. So the spring potential energies are going to be highest at the amplitudes when they're switching directions, and then the kinetic energy is highest in the middle. Kinetic energy is highest in the middle because there's no force from the spring on either side, causing it to have an acceleration in the opposite direction of motion, which would cause it to slow down. But instead, there's no force acting on it, so that's when we're going to have all the kT here is in the middle. There's no force acting against it or for it. Then for the US's, on the spring potential energy on each side, because we're changing direction here, we're going to have a momentary velocity of 0 as we change directions. We can see this on the velocity time graph up here, the momentary velocity of 0. And if we have a 0 velocity, this drops to 0, so all of our energy is in spring potential energy. And the spring potential energy is useful because if we have an amplitude, and this is an assumption, and use this carefully, but if you are at the edge, then all of your energy is going to equal 1/2 kx squared, which is equal to 1/2 ka squared, a being your amplitude. This is only for at max on each side. So a is your amplitude here. And so that's going to be useful in solving a lot of problems to get. If you know where you are in your oscillation, you can set that equal to your amplitude and you solve for k and some things. Also keep in mind that t equals 2 pi root m over k as well. So there's another way to find k if you have a mass. Or if you need a mass and you only have an amplitude, you can find that using this and then get to here through that. So those are some ways to use that using energy and oscillation. And the same goes for if you have the velocity, then it's going to be only that velocity when it is in the middle of the oscillation, and using that to find stuff. So that's energy and oscillations and kind of some stuff to know about it and what you can do with it and how to use it. Thank you for watching.